All right, hey everybody. We are going to be doing our next unit. This is going to be unit 2 and it is called biochemistry. And so please make sure you have out your notebook and a pen or pencil so you can follow along with me, and be sure to pause the video if you want to write something down and just quickly jot that down in your notebook. All right, so we're going to get right into it. It's all about biochem. So here we have, this is the way you spell it, biochemistry, and this is lecture 2.1. Biochemistry is a very important topic, even though you might think, okay, this is biology, why are we learning about chemistry? But it's really important to understand interactions that happen within the molecules, and how electrons are moving and what's the importance of protons, and we're going to get all into that. So here we go. So the first thing we want to talk about is the atom. So the atom is the basic unit of a chemical element. This is the smallest unit of matter. So we talked about, when we looked at characteristics of life, the smallest unit of life is a cell, but the smallest unit of a matter, of an object, is an atom. And so we want to look at the different components that make up the atom, and that'll help us understand how different atoms interact with each other and how that relates to biology. So it's really important to understand the basic unit of matter so that we can kind of bring it out and understand how that influences life all around us and objects all around us. And you'll see here it says atoms are put together to form molecules. So one atom is not enough. Atoms are so small. So they have to attach to each other. We call those, they have to bond to each other in order to form molecules, and then molecules will eventually form objects and living things. So we want to look at all these different components. And here are some examples of atoms. We have a carbon atom. Carbon is a really, really important atom that we're going to be really talking a lot about for this particular unit, and for basically all units, because every living thing is made of carbon. So it's a very, very special element and atom that we're going to talk a lot about. And you'll notice here that it has several different components that make it up. There are protons, there's neutrons, and there's electrons. And we're going to look at each of those components. And you can kind of see this is the basic look or model of how scientists represent what an atom, how it kind of looks. And so we have this inside here is called a nucleus, and it has protons and neutrons. And then on the outside of the nucleus, we have these little red dots, and those red dots are called electrons. And we will go more into that on the next slide. But here are just some examples of what atoms, what the model of atoms look like. So we have the magnesium, we have the calcium there. So there are 3 subatomic particles that make up an atom. So any atom is going to have these 3 components. It's going to have protons, and protons are positively charged. That's why there's a plus sign there. So if you see anything with a plus sign, that's an indication that it's a proton. It's positively charged. And this is found in the nucleus. So here's this model up here, and you can see here those plus signs, they're in red. Those are the protons, and they are found within the nucleus, which is the center of the atom. Then we have our neutrons. Neutrons are also found in the nucleus, the center of our atom, and they are neutral charged. So that's why you don't see anything inside of the nucleus. They are neutral. So what does that mean about the center of the atom? Because we only have positive charge, that's saying that the inside of our atom is positively charged. Now, what about the outside of our atom? These are these little things out here. What are those? Those are electrons. And electrons, like you see here, has this negative sign. So that's telling us that they are negatively charged. And these are found on the outside of the atom. So they are surrounding the nucleus of the atom. And these are really, really important. These are the subatomic particles that are going to actually be interacting with other atoms and with other objects. And we'll look at that on the next slide. So electrons, once again, very, very important. They are on the outside of our atoms, and these electrons are going to be directly involved in chemical activity of an atom. Protons do not move. They stay, protons and neutrons, they stay on the inside of the atom. They stay in the nucleus, and they're not going to move. But the electrons, which are found on the outside of our atom, they do interact, and they can move around. And we're going to look at how do they move. Sometimes they'll be transferred to another object, or sometimes they'll just kind of move over, or sometimes they'll share electrons. And we're going to look at those different interactions as we go through this unit. Like we talked before, electrons are going to move around the nucleus, and there's something called an electron shell. So it's not like there's actually, if you find an atom and there's actually rings around it, we just represent them as rings because they kind of go in like circles like this. But it's really a better word to use is there's a shell, and they just surround the nucleus. All right, oh, going too fast there. And so that's some important facts about electrons. So here, looking at the electron shell, when we are looking at the different orbitals that are going around the nucleus, or when we're talking about our atom, the first orbital, and we can kind of see it here. Let's look at neon. So we see Ne is here. Remember, what's found inside the nucleus of an atom are the protons and the neutrons, and those don't move. Those stay within the atom. They're not going to move. Then on the first ring right here, we call this is our first electron shell, our first orbital. We have it. We're going to mark it with the number 1. How many electrons can go on this first ring or this first orbital? Only 2 electrons. So it's a maximum of 2 electrons can fit around this first orbital. Once 2 electrons fill that first orbital, then we can move to our next orbital, which is the second orbital. The second orbital can only contain 8, or a maximum of 8 electrons. And then once that's full of 8 electrons, then we move to our third orbital, and that can have 18 electrons. We're really, for biology, we're not going to get, mostly we will be dealing with elements, atoms that we only really get to the second orbital. When you get to chemistry, you'll probably be looking at atoms that are much larger, and in the sense that they have a lot more electrons. But we aren't really going to go that deep into it. But if you ever want to figure out the number of electrons that can go in that particular order, you can use the equation. Let's see, I'll write it down with my pen here. You can use the equation 2n squared. And so n is representative of the orbital. Oh man, orbital. So it's representative of the orbital. So if we're looking at orbital number 1, you plug that into the equation. Now so what that means is actually you have to do n squared. So if we have our first orbital is 1, you put in the 1 right there, then you square it, that's still 1 times 2 is 2. So you can plug in the number of orbital in there. We won't really do that, but just for your information. And what atoms want to do is they want to form an octet, meaning they really do want to form that second orbital with 8 electrons. So neon, you can see there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons, and that's called an octet. So octet is referring to 8 electrons. And you'll notice the way I represent electrons is I put an E with a little negative sign, as opposed to writing out electron, just a little faster. But an octet wants to form 8 electrons in that second orbital. And so you'll notice that what's going on here? This is carbon, and there's 1, 2, 3, 4 electrons. It can really have a maximum of 8 electrons. And so carbon is a really special element. It's an atom that interacts with a lot of different things, and it can form a lot of bonds. And that's why it's so important to life, because of this property. And we'll look more about that. But really, we want to understand this idea that they really want to fill that octet. So here, clear that screen, we want to look at this idea of something called a valence shell. The valence shell is going to be the outermost layer of the atom. So those are our outermost electrons. So the valence shell, if we're looking at oxygen, so we have this O here, that means oxygen, is going to be here. This is the valence shell, and these outermost electrons are called the valence electrons. And the valence electrons are going to be the ones that actually interact. So these two on the inside, in this first orbital, they're not going to really interact because we have these outermost electrons. Those are the ones that are going to be interacting with other atoms or other molecules. So that's something to kind of keep in mind. We also have this idea of a noble gas, and I have 2 examples of a noble gas here. Noble gas means that it's a very stable element, very stable atom. So helium, remember that that first ring has a maximum of 2. And guess what? Helium has filled up its first orbital. And so it doesn't want to interact with any other elements or any other atoms or molecules. It's perfectly content just the way it is. Just like neon, right? We have 8 electrons on that outside. We want to form that octet. It already formed that octet. So it's stable and it doesn't want to interact. It just wants to be left alone. And here, this is our periodic table, which we'll be looking at quite a bit for this unit. And what it's referring to is it really tells us a lot of information actually about our different elements and how they can potentially interact with other elements. So here is a good example, and we will look at this more in our next presentation, but this is telling us a lot of information. It tells us the number of electrons, it tells us the number of protons, and it tells us the number of neutrons. So if we're looking at potassium, which is represented with a K, which is kind of weird, but that's the symbol for potassium. It tells us up here, if we're looking at this number in the corner, this is the atomic number, and the atomic number tells us the number of protons. What's important to recognize is this idea that for our elements on the periodic table, they're in a neutral state. So that means that the number of protons is going to equal the number of electrons. So if you have, for instance, 19 protons, which are positively charged, and then you have 19 electrons, which are negatively charged, that's a neutral charge. And so everything on this periodic table is neutral. So that means that if you can figure out the number of protons, you can also figure out the number of electrons. So because there's no plus or minus after the number, we know it's neutral. And then here, this number right here, this larger number, sometimes larger number, is the atomic mass. And so what that is telling us is that that is the number of neutrons and protons. And so if you have a number of protons and you have this atomic mass, you can actually figure out the neutrons by taking 39 and minusing it from 19, and that gives you, oh, we got 20 neutrons in this atom, in this element. Okay, so that's just a quick review of that, but a quick overview of that, and then next lecture slide or lecture presentation, we will do a lot more on that information. All right, so that's all I have for you for this presentation. If you have any questions, please let us know, and I hope that was helpful. Have a great day.